So we'll look at problems from chapter 11. So the first problem asks us to look at this one over here. We are given a table of stock prices and dividends that have been paid over certain periods of time. So from here, the question is, what is your realized return? And the realized return, what it is generally alluding to over here, is calculate your geometric return. In other words, had you invested $1 at the beginning of the period, January 1st, and went through all of those changes in stock prices and got those dividends, then what would be your return at the end of that year? So to do this, we have to calculate I'm essentially going to extend this table out, and from here I'm going to calculate return. Return over here, 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 and here, 4 returns. Each of these returns will have the same process. Stock price at the end minus stock price at the beginning plus any dividend divided by stock price at the beginning of the period. So over here, for March 31st, it is going to be stock price at the end, which is 11, minus stock price at the beginning, which is 10, plus the dividend, which is 0.2, divided by 10. For June 30th, it will be 1050, which is end. The beginning stock price is now going to be 11. So the change in stock price from March 31st to June, that is, so beginning stock price is 11, plus again the dividend, divided by 11. For period 3, it would be 1110, and the beginning now would be 1050, plus 0.2 divided by 1050. And for the last period, it would be 11, end price, beginning price is 1110, plus 0.2 divided by 1110. So if we do the math, we will find that the return for the first period is 0.12. For the second period is negative 0.027. Negative 0.027. For the third one is 0.076. And for the fourth one, it is 0.009. So those are our returns each year. So we can label this R1, R2, R3, R4. So if you put this on a timeline, it would look like this. So 4 periods. So the return over the first period is 0.12. Return over the second period is negative 0.027. Return over the third period and return over the fourth period. So then the question is, what is the return over this entire period from here to there? Had you invested $1 over here, had you invested $1 here, what would that dollar grow to? Well, the dollar from here, from time 0, would grow to $1, would grow to 1 plus 0.1. essentially it will be the future value. So the future value of $1 at the end of the first period would be $1, 1 plus 0.12. That's $1.12. So that's what we have at the end of year 1. Then what would we have at the end of year 2? Well, now that 1.12 would grow, or in this case decrease, by 0.027. So I take 1.12 and I multiply that by 1 minus 0.027. And I keep on doing this for 2 to 3 to 4, and I get to the end point. Or we can directly go into the formula for geometric mean, which would be 1.12 times 1 minus 0.027 times 1 plus 0.076 times 1 plus 0.009. So we take the product, 1 plus the product of each of these periodic returns. Then we raise this whole thing to the power 4. We raise it to the power 4 because there are 4 periods. So in essence, we take the product of those 4 numbers. I don't want to raise it to the power 4 because I don't want to annualize it. So I'm going to, I don't need to raise it to the power 4 right away. We'll see this later on when we get to another problem when we have to raise it to the power 4. Right now, all we are doing is looking at by how much is this $1 growing over time. So $1 grew to 1.12, then it grew by this much, so we multiplied, then we grew by that much, it grew by this much, so we take the product of all of these, and though that product comes to 1.183. 1.18, so let's see. We'll check over here. So clear everything here. So it's 1.12 times so this will be 1 minus 0.027, that's 0.973 multiplied by 1.12, so that's 1.08. So at the end of period 1, I have 1.08. Now that I'm going to grow, I'm going to multiply that by 1.076, 1.076. So that's 1.726. So at the end of period 3, I have 1.1726. And then that one I'm going to grow at, multiply that by 1, multiplied by 1.009. 1.1726 multiplied by 1.009. So that gives me 1.1832. 1832. So 1.1832 is the amount of money I ended up with after I invested $1 today. After I invested $1 into this stock. That means my return over this period is going to be 1.1832 minus the $1 we started with, which is 1832 or 18.32%. Okay, so that's problem number 6. Let's take a look at problem number 11. This is where we'll do both the geometric return as well as the arithmetic return. So we will look at both calculating geometric return as well as arithmetic. So I'm just trying to find out in your textbook where is this on the test. Okay, let's see. So you can follow this properly over here. Yeah, so you can look at equation 11.2, which is the equation that we just used in this problem that we just did, problem number 6. Okay, and then when we look at geometric return, which is, we are looking at problem number 11, the first step is how to calculate arithmetic return. Arithmetic return is pretty simple. Arithmetic return is just the average of these numbers. So all we have to do is add all these numbers up and divide them by the number of observations. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 observations, so we add all those numbers up, divide that by 10, and that gives us arithmetic average. So arithmetic average, we can often represent that by R bar. I'm just going to make it clear over here. This is arithmetic average or simple average. It will be negative 19.9 plus 16.6. I can leave them as decimals. I don't have to leave them as percentages. I don't have to convert them into decimals for the purposes of this problem. So this would be negative 50 plus 43.3 plus 1.2 negative 16.5 plus 45.6 plus 45.2 negative 3. We take all of that, divide this by 10, and the answer is going to be 8.05. That's our arithmetic average in percentage. Now to calculate geometric average, each return will have to be converted into what is called a wealth relative. I'm going to do this right under the original problem to show you, illustrate this to you, and then you can repeat it on your own to complete the problem. I'll illustrate this over here. How we convert the annual returns into what is called a wealth relative. So a wealth relative is essentially 1 plus R. So 1 plus R1, 1 plus R2, 1 plus R3, these are all wealth relatives. So this one would be 1 plus point or 1 plus minus 0.199. So it will be 1 plus, but this is minus 0.199. So that's the wealth relative for year 1. And that's going to be 0.801. That's the wealth relative. Next one is going to be 1 plus 0.166. So this would be 1.166. This would be 1.18. This would be 0.5, 1 minus 0.5. This would be 1.433. This would be 1.012. This one would be 0.835. This would be 1.456, 1.452, and this would be 0.97. So now I have the wealth relative for each of the 10 years. Then I will take the product of all of these. It will be 1.012. And 0.97. So I have the product of this whole thing. Now I will have to raise this to the power, because I have this, these are my year-by-year numbers for the last 10 years. So that means if I invested $1 over here at time 0, at the end of 1 year, that $1 went down to 80 cents approximately. Then the next year that 80 cents grew by 16.6%. Then the next year that number grew by 18%, and so on and so forth. So now I want to take this 10-year series and convert that into what's the average rate of growth for each year. So I will take all of that, raise this to the power 1 over 10. I raise this to the power 1 over 10 to reflect that there are 10 observations over here, so 10 periods. So when I raise this to the power 1 over 10, the product of all of that raised to the power 1 over 10 comes to 1.03176. 1.03176. Now to get the geometric average, what I will do, so R, geo mean, or geometric mean, is going to be 1.03176, which is the product of all of this, raised to the power 1 over 10. I will subtract 1 from it, 0.03176, which would be 3.176%. So you can see that the numbers are quite different. For the same series of numbers, geometric mean and arithmetic mean will have 2 different numbers. Now, which number is closer to reality? To answer that, you have to follow this process. Take $100 and keep on growing it each year by the amount or the percentage of this year, for that year. So you take $100, you take $100, so $100 at the end of year 1 would be 100 times 0.801. So that would be $80.10. Then you take $80.10 and grow that. So it will be 80.10 multiplied by 1.166. So 80 times 1.166. 80 times 1.166. That's 93.28. And we keep on repeating this. We keep on repeating this until we get to the very end, and the answer would be closer to this number. That $100 times 0.03176, or 1 plus 0.03176, that'll be about $103.17. $103.18 would be your final number. So that's problem number 11. Problem number 16, how to calculate average annual return and variance and standard deviation. So this is a time series distribution, so we can convert this into a table. So time is 1, 2, 3, 4. For that time period, we have returns of -4, 28, 12, and 4. From this, I can calculate my average return. And average return would simply be, I add this up, so -4 plus 28 plus 12 plus 4. So average return, -4 plus 28, that's 24, 24 plus 12 is 36, 36 plus 4 is 40, so 40 divided by 4, so the sum of that divided by 4, so that's going to be that's going to be 10%. So average return is going to be 10%. Once I have average, then, so what's the average annual return? R bar is 10%. Then I'm going to take return, each observation, minus its mean, and I'm going to square that. So -4 minus 10 squared, 28 minus 10 squared, 12 minus 10 squared, 4 minus 10 squared. And then I can calculate this. So this is -16, so 16 squared. 16 squared is 256. Then I have 18 squared. Eighteen squared is 324. And 12 minus 10 is 2. 2 squared is 4. And 4 minus 10, that's 6. 6 squared is 36. So 324 plus 256 plus 4 plus 36. So that gives me 620. So if I add all of this up, if I sum all of this up, that equals 620. I divide 620 by 3. Why 3? Because there are 4 observations, and I always divide by n minus 1. So 620 divided by 3 is 206. Uh, 14 squared is 196. So the first one is 196, not 256. So 196 plus 324 plus 4 plus 36 is 560. So this is 560, and 560 divided by 3 is 186. 186.67. This 186.67 is considered variance. And if you have to put this in decimal format, I suggest you calculate everything is in percentage format. And to convert this into decimal, this would be 0.018667. So you move the decimal point 4 places to the left. So you get the percentage and then you move the decimal 4 places to the left. So what's the variance? You can either write this as 186.67 or 0.018667. Finally, what's the standard deviation? I take the square root of 186.67. So I take the square root of that, 13.66. Or I can put this in decimal, 0.1366. Either way would work. Question number 20 is about time interval, confidence intervals. You have average return is 12%. So average return is 12%, and standard deviation sigma is 20%. 95% confidence, what's the range? So 95% confidence implies plus minus 2 standard deviations. Plus minus 2 standard deviation. So it is 12 plus minus 2 times 20. Plus minus 2 times 20. That means it will be 12 plus 40 and 12 minus 40. So this would be 52 to 28. The range would be 52 to 28. So the question is, can you be 95% confidence that the portfolio will not lose more than 30% of its value next year? So this is minus 28. So this is plus 52 to minus 28. So since this is minus 28, the low end of the prediction interval is minus 28, which is greater than 30%. So the most it can lose is 28%, which is it will not lose more than 30%. So the answer would be no. Yes, I'm 95% confident that the portfolio will not lose more than 30% of the value, because the low end, second standard deviation low end is negative 28. So that completes the problems from chapter 11.